Welcome to chemistry class. Today's topic is solubility product. Let us define what is solubility product. Solubility product can be defined as product of concentrations of ions which are in equilibrium with solid state which are in equilibrium with solid state of the salt. So this is solubility product. This is significant in case of sparingly soluble salts. This is significant in case of sparingly soluble salts. Okay. So now let us discuss the definition in detail. Product of concentrations of ions which are in equilibrium with solid state. Which are in equilibrium with solid state. Okay, let us see what is that. So when you consider a sparingly soluble salt AB, okay, so it is like this when you dissolve in a solvent. Okay, so here let us see, if the solvent is water, then A plus will be in aqueous state, B minus also will be in aqueous state, and AB considered as solid. Being AB is a sparingly soluble salt, the situation when it dissolves in water will be like this. Here this indicates AB which is present in solid state, and this indicates A plus aqueous plus B minus aqueous. Okay, at this particular situation one can consider that there is equilibrium in between liquid and solid. So here we can assume that the ions present in liquid state are in equilibrium with the solid state. Okay. So in such case solubility product will be triggered. Okay. So as per definition, the product of concentrations of ions which are in equilibrium with solid state. Here these are ions and this is solid state. Okay, this is equilibrium in between the ions and the solid state. Okay, that is said to be solubility product. So now let us see how can write the expression here. KSP. Here SP denotes solubility product, K denotes constant. So overall KSP can be considered as solubility product constant. Let us see for this how we can write solubility product constant. Okay, so the concentration of A plus into the concentration of B minus divided by concentration of undissociated substance or A. Is it clear? So being AB is in solid state, some of the substance left over in solid state that has to be removed from this expression, since AB is equal to concentration of AB is considered as unity. Unity means 1. then the expression will becomes like this. KSP is equal to concentration of A and concentration of B. This is to be considered as solubility product of AB type sparingly soluble salt. Is it clear? So that is about solubility product. Here the important thing is the product of concentrations of ions which are in equilibrium with solid state. Okay, which are in equilibrium with solid state. By observing this illustration, you can get clarity. Is it clear? Applications of solubility product in precipitation reactions. Let us see. Applications of solubility product in precipitation reactions. Precipitation AgNO3 plus NaCl gives rise to AgCl plus NaNO3. Here this is aqueous, this is aqueous, this is also aqueous, this is precipitate, this is solid. Okay. Here you are adding two types of aqueous solutions, that is AgNO3 and NaCl. Here the immediate addition of AgNO3 to NaCl, you can get AgCl and NaNO3 as superadded. Let us see what will be there. So let us assume that this is the container in which we are going to react AgNO3 and NaCl. Okay. See here, this contains aqueous NaCl. You are adding aqueous AgNO3, okay, into this solution. Let us see, after completion of the reaction, the situation will be like this. Here AgCl forms as precipitate. Okay. In the solution, Na plus ions present in aqueous condition and Cl minus ions present in aqueous condition. Is it clear? So here the question is, why AgCl getting precipitated here? AgCl అనేది ఎందుకు precipitate అవుతుంది? Why don't NaNO3 is precipitating? Why don't AgNO3 remains as precipitate? Okay, ఎందుకు ఇక్కడ AgCl మాత్రమే precipitate అవుతుంది అంటే we can explain that on the basis of solubility product. Okay, here the condition for precipitation is, let us see, the condition for precipitation is solubility product always should be less than ionic product. Okay, so because this only precipitation will happen. So let us see here, among all these compounds, for AgCl only, solubility product means we can denote it KSP is less than ionic product. Here ionic product can be represented as Q. Okay. For remaining all substances, for remaining all compounds, ionic product is less than solubility product. Okay. For this one, for this one, for this one. For these three compounds, okay, ionic product is less than solubility product. So they are not getting precipitated. Okay. For AgCl only, ionic product is greater than solubility product, or solubility product is less than ionic product. Is it clear? So, by knowing solubility product, we can explain that by knowing solubility product values, we can explain which substance get precipitate and which substance cannot get precipitated. Is it clear? So I am repeating the condition here. If you want to get precipitate a compound, for that particular compound, solubility product always should be less than ionic product. ఒక చిన్న విషయం చెప్తున్నాను నేను. సాల్యుబిలిటీ ప్రోడక్ట్ తక్కువ ఉంది అంటే డిజాల్యూషన్ తక్కువ ఉన్నట్టు. ఇస్ ఇట్ క్లియర్? సాల్యుబిలిటీ ప్రోడక్ట్ అనేది తక్కువ ఉంది అంటే డిజాల్యూషన్ తక్కువ ఉన్నట్టు. సాల్యుబిలిటీ తక్కువ ఉంది అంటే ప్రిసిపిటేషన్ అనేది ఆటోమేటిక్గా జరుగుతుంది. ఏదైనా ఒక సబ్స్టెన్స్కి సాల్యుబిలిటీ తక్కువ ఉంది అంటే ఏమని అర్థము? ఇట్ రిమైన్స్ యాజ్ సాలిడ్. The remaining as solid is said to be precipitation. Okay. So here the favorable condition for precipitation is solubility product of that particular compound always should be less than ionic product. Okay. Thank you.